yeah, that a, let's say that a to the power of, let's say, c over d is the same as a to the power of c raised to the power of 1 over d, okay? We multiply exponents, which when we have an exponent raised to an exponent, when we multiply exponents, we'll get this particular c over d. So we can actually break this up now to be, therefore we have f prime of x is equal to the limit of the natural logarithm, okay, of 1 plus 1 over n raised to the power of n. Wow, that looks now like this thing here, but that this thing here is all raised to the power of 1 over x, okay, as n tends to infinity. And because this is an exponent, okay, associated with the natural logarithm, we can bring the exponent down. So what we're actually doing is we're applying this rule now again. This time we're going from left to right. So this becomes, therefore, we have f prime of x is equal to the limit of 1 over x times the natural logarithm, okay, of 1 plus 1 over n raised to the power of n, okay, as n tends to infinity. Okay. Now, we have a limit, okay, we have a limit of a product here. So that's the same as the product of the two limits. So therefore, we have f prime of x is equal to the limit of 1 over x, okay, as n tends to infinity, times, that's the first, this is the first part, the left operand on this product here. So the limit of a product is the same as the product of the limits. So now we get that's equal to the limit of 1 over x times n as n tends to infinity times the limit of the natural logarithm of 1 plus 1 over n raised to the power of n as n tends to infinity. Now, as n tends to infinity with respect to this function here, 1 over x, well, when n tends to infinity, so what? Okay, it has no effect on 1 over x. 1 over x tends to 1 over x. So therefore, we have that f prime of x is equal to this limit here, okay? This part of the limit here actually evaluates to 1 over x times the limit of the natural log of 1 plus 1 over n to the n. We can take the natural log out and we get the natural log of the limit of this. So this becomes the ln of the limit of 1 plus 1 over n to the n as n tends to infinity. But voila, this piece here is just the definition of the exponential number. So actually this now becomes, therefore we have f prime of x is equal to 1 over x times the natural logarithm of the exponential function e. Okay? Now these are only definitions. Like, I mean, before we started this particular procedure here, okay. So before we actually started this, whoops, where have I gone to here? So before we started this, we assumed that we knew what the ln of x was, okay. So it's all defined. We also defined the number e, and we know what the number e is. It's the limit of 1 plus 1 over n to the raised to the power of n as n tends to infinity. That's what we're defining to be e. And the natural logarithm is the inverse of that particular function. So actually what we end up with, the natural logarithm, the ln of e, well, the ln of e is simply equal to 1, okay, from our definition of ln and our definition of e, where the ln is, we're assuming, is to the base e. So therefore we have that f prime of x is equal to 1 over x. Voila, okay. What we're really saying here, what we are saying, okay, is that the ddx of the ln of x, the derivative with respect to x of the natural logarithm in x is equal to 1 over x. And that's what we wanted to show from first principles. We wanted to show the derivation of the natural log function, which is exactly what we've just done here, if that makes sense. Okay, guys, once again, this is Jonathan Lambert with Maths and Stats. And I hope that this video, another video in a series of videos dealing with calculus and differentiation from first principles, I hope that was intuitive. And more importantly, I do hope that was helpful for you. And thanks for watching. Okay, bye bye.